look at the rational root theorem and how it helps us solve questions like this. So in example 1, we want to factor x cubed minus 13x minus 12. And thinking back through all my factoring techniques I've had up until now, none of them have been able to help me solve something like this. I think rational root theorem is going to help us out because when we say factoring x cubed minus 13x minus 12, we mean several things. So in other words, let's write this function as f of x equals x minus a times x minus b times x minus c. Here I mean f of x being the polynomial we're trying to factor. Okay, so we could factor it as three different things. That's one thing they want us to do. Another way of thinking about this is to locate the x-intercepts. If I was going to graph f of x, where does it cross the x-axis? That's another way of factoring my polynomial. Another way to think about this is to find the zeros of f of x. And if you remember, the zeros are the x values that if I plug into my function, I get 0. And if you remember, the zeros of a function are the values of x so that when I plug them in, I get 0. Okay, so that's three different ways to think of a factoring question. And this third one in particular makes me think, okay, finding zeros of a function, oh yeah, division helps me do that. If you remember, if I do division on this polynomial and I get 0 as a remainder, then I have factored, I have found a 0 of my polynomial. So that's what we're going to try to do. Okay, now the thing is, we're trying to figure out if I'm going to divide, I need to divide by something. So what do I need to divide this by? If I made a list of candidates of things to try to divide this function by, and I'm thinking in synthetic division, so my k values, I could have maybe plus or minus 1, how about plus or minus 2, plus or minus 3, plus or minus 4, and honestly, there are an infinite number of things that we could possibly try to divide this by, and hopefully we just get lucky and find one, but what if we don't? Okay, so we need some way to maybe whittle this list down from an infinite number of things to just maybe a small number of things, and that's what the rational root theorem does. Alright, so let's state what the rational root theorem says. Alright, so now what the rational root theorem says is let's let p of x be a polynomial written in this way, a sub n x to the n power plus etc. etc. And the key components to this is that I have a leading coefficient of a sub n and a constant term of a sub 0. Those are the two things I need to keep up with. And we also have a 0 here, so this p over q is a 0, and we do write it that way because this is a rational root for the rational root theorem. If we have that, then a sub 0, so my constant term, is divisible by p. So the numerator of my root divides the constant term, and a sub n is divisible by q. So in other words, the denominator of my root divides my leading coefficient. So that will help me come up with a candidate list for when I'm trying to factor something like we just had, like x cubed minus 13x minus 12. So first of all, let's think of what our constant term, our constant term is negative 12, and our leading coefficient is 1. So the things that divide these numbers respectively, for negative 12, what can divide negative 12? How about plus or minus 1, 2, 3, 4, 6, and 12? A lot of things can divide 12. And how about for 1? Well, not a lot, plus or minus 1. So that means if I have a rational root, they look like this. The candidates for my rational roots are coming from this list. Plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, 4 over 1, 6 over 1, 12 over 1. Okay, and where do we get that again? Remember, for your rational root, p over q, so these are my p over q's here, the numerator divides my constant term. So the numerator has to divide a negative 12, and the denominator, that q, has to divide 1. So that is the list that we get when we try thinking of the things that can divide negative 12 and 1. Okay, now, so sometimes my students think, well, wait a minute, that's 1, 2, 3, 4, 5, 6 times 2. That's 12 different things we could try. Yeah, that's 12 different things we could try, but we start out with an infinite number, remember? So we've whittled it down from infinite down to 12. That's pretty good. Now, how do you figure out which ones to use? Well, that's where synthetic division comes into play, and we will have to do some guesswork. So let's just try it. So I'm going to try to divide by 1, and I'm going to use synthetic division. So that's 1x cubed, 0x squared, negative 13x, negative 12. And if you don't remember how to do synthetic division, I do have a video covering synthetic division. Maybe you should look that up, and maybe it can help. Alright, so the way we do this is we bring down the 1, and then we say 1 times 1 is 1, and then we add 0 plus 1 gives me 1. And we just do this again. 1 times 1 is 1, plus negative 13 gives me negative 12. Negative 12 times 1 is negative 12, and negative 12 plus negative 12 is a negative 24. And here is the tell. That's my remainder. The remainder is not 0, so 1 is not a root. Okay, so that's a failure, but even in failure, it's helped us because we have now eliminated one possibility. Positive 1 is not going to work. Alright, so we'll move on. Let's try negative 1. So if I do negative 1, we have the same coefficients here. Let's see what we get. So we bring down 1. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. So negative 13 plus 1 is a negative 12. Times a negative 1 becomes a positive 12. And look what we got here as a remainder. We got a 0. That's really exciting. So that means that negative 1 is a root. Okay, so we have partially factored this thing. This means that my function now could be written like this. X cubed minus 13x minus 12 is x plus 1. Where did I get the x plus 1? Remember, negative 1 was a root. This is x minus a negative 1 times x squared minus x minus 12. And where did I get that? Well, that is the quotient that I get from division. So there's where I get the x squared minus x minus 12. So it's partially factored, and now since what I'm left with is quadratic, I can factor that because we have a whole round of techniques to help us do that. So we get x plus 1 times two things that multiply to give me negative 12 and add to give me negative 1. How about negative 4 and a positive 3? And there we have it. Look, we have factored this polynomial, and what's incredible is that until today, we couldn't factor it using the techniques we knew. So the rational root theorem and synthetic division do help. Alright, so let's look at one more example. So this time we want to factor 2x cubed plus 11x squared minus 20x plus 7. And again, I don't have any indication on what the right way to do this is. So let's just create a candidate list. Okay, so remember we're talking about p's and q's. And remember the p, the numerator, divides what? Divides the constant term. My p list could be things that divide 7. There's not a lot that can divide 7. How about plus or minus 1 and plus or minus 7? Q comes from the leading coefficient. Here it's 2, so that's going to be plus or minus 1 and plus or minus 2, the things that divide 2. Okay, so from that we can combine these and get a list of, how about plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 7 over 1, and plus or minus 7 over 2. Okay, and that's 1, 2, 3, 4, plus or minus. That's 8 things that we have to try. Possibly, at most 8 things. Alright, so let's just pick one to try. Any suggestions? I got a suggestion. Let's try 1/2 here, and I want to use 1/2 to show that even with fractions, synthetic division works. So I have my coefficients here, 2, 11, negative 20, and 7. And we're just going to do synthetic division, so I bring down the 2. 2 times 1/2 is 1, plus 11, you get 12. 12 times 1/2 is 6. Negative 20 plus 6 is negative 14. Negative 14 plus 1/2 is negative 7. And here, look, we get a remainder of 0. It's a cause for celebration, right? Because this is a root. Not only that, now our polynomial can be written as 2, instead of saying 2x cubed plus 11x squared minus 20x plus 7, our polynomial can be written as x minus 1/2 times 2x squared plus 12x minus 14. Okay, now I can factor the rest of this because it's quadratic. And actually what I can do first of all is factor out a 2. So I have 2 times x minus 1/2 times x squared plus 6x minus 7. Okay, so now I just think of two things that multiply to give me negative 7, add to give me positive 6. I know. How about positive 7 and negative 1? Alright, and there it is. It's factored. Now, commonly, you wouldn't write 2 times all this, especially when there's a half involved. So if you want to clean it up a little bit, you can distribute that 2 there and end up with 2x minus 1 times x plus 7 times x minus 1. But we get the same list of zeros. It's the same thing. Great. So I hope I have convinced you that the rational root theorem is something that's useful. In particular, synthetic division is useful. Guys, I used synthetic division a lot, even in my PhD dissertation, to help me figure out roots of polynomials quickly. If you have any questions on this, I'd be glad to help, and thank you for watching.